I know that short test 2 was something that a number of you might have wanted to erase from your memory, yet take a deep breath and review it with me here in this short video that will give you the solutions. Question 1 was a number of short answer questions. For part A, you could have listed any 3 of the following. 1. Correlation is only for linear relationships. Regression can look at linear relationships also, but also things like curvilinear, polynomial, etc. can be done with regression. 2. Regression can look at the effect of more than one explanatory variable on the response variable. 3. Correlation is measured using the correlation coefficient R, which ranges from -1 to +1. 4. A regression relationship can be described with a regression equation. 5. A regression can be used for prediction. And 6. A regression is used for a cause and effect relationship. Please note that if you told me one of these regarding regression, for example, cause and effects, and then that correlation is not a cause and effect relationship, then that's still just the same point. Part B, the Shapiro-Wilks test investigates the normality of the dataset. The null hypothesis is that the dataset is normal. Part C, Bartlett's test looks at equality of variance between given datasets. The alternative hypothesis is that variances are not equal. D, the 2 types of variance that are at the heart of ANOVA is the variation that is present between treatments as well as the variation within treatments. E, coefficient of determination measures the amount of variability in the response variable explained by the independent or the explanatory variable. You needed that definition. F, this research setup has 2 factors, so it's a two-way ANOVA. Therefore, a bell should have gone off that you must have also put 3 hypotheses here. The first would be the average weight of the 4 different species of frogs is not equal. Second, the average weight of frogs in 3 different habitats is not equal. And the third, the average weight of different species of frogs occurring in different habitats is not equal. For question 2, you are given R output including a scatter plot. The type of test that was being run here was a correlation test. Correlation tests look at relationships between 2 variables, yet it is not a cause and effect relationship. So, even if you see that heart weight was plotted on the y-axis, there is still actually no real response variable for this test. The correlation coefficient is 0.8041274. You can read that off the R output. This value indicates that there is a strong, positive, and linear relationship between the 2 variables. The coefficient of determination is the correlation coefficient squared. So 0.804 squared equals 0.64662. Question 4 gave you more R output, this time for regression. The question said, a psychology student decided to investigate how the number of problems in a person's life might impact on their anxiety level. So the number of problems is the explanatory factor and should be on the x-axis, whereas the anxiety level is the response variable and should be on the y-axis. For parts B through E, you must use the R output. Part B asks whether anxiety levels is significantly affected by the number of problems a person has. So what this is really asking is, does the regression line have a significant slope? The estimate for slope is 0.25259, and it is significant because we have a p-value of less than 0.05. So yes, anxiety levels are significantly affected by the number of problems. For questions C through E, we need to use the regression equation, which is y equals 0.25259x plus 5.42265. If you're a bit uncertain about this equation, make sure you watch the R output from Simple Linear Regression video. So part C, if anxiety equals 33, this means that y equals 33. Plug this into the regression equation and you'll get x equals approximately 110. So this is the number of problems that would cause this level of anxiety. Part D, if number of problems equals 20, then x equals 20. Plug this into the regression equation and you'll get y equals 10.47. So this would be your predicted anxiety level when you've got 20 problems. The last question asked you what would happen to anxiety levels if you had no problems. So what this question is actually asking is, if x equals 0, i.e. you have 0 problems, what is the value of y, the anxiety level? This means that what you're actually looking for is the y-intercept. You could answer this in two ways. Either from the R output, you could directly read the value of 5.42265 as the y-intercept and note that it is significant with a p-value of 0.034. Or you could plug x equals 0 into the regression equation and you'd come up with the same value. By the way, thank you for all of you who made me smile and gave me philosophical answers for Part E about how anxiety and problems affect people's lives. It wasn't quite what I was looking for, but I also know you had your own level of anxiety given the problems you were trying to answer at the time. Question 4 was a short one about other types of regression that were mentioned in our class. The equations are here. Some things you could have added were polynomial regression adds at least one curvilinear term into the regression equation, or multiple regression adds at least one additional explanatory variable for which a separate slope is estimated into the regression equation. In question 5, you had some ANOVA output to deal with that was related to pain relief medicine. The first question was about knowing the assumptions of a one-way ANOVA. When asked why ANOVA was used instead of regression, you could have said, 1, the explanatory variable is categorical, not an interval or ratio data type. And 2, it is a test for differences, not for a relationship between variables. When asked why the one-way ANOVA was used instead of Kruskal-Wallis, you could have said, 1, the data is normally distributed. This information is found in the Shapiro-Wilks test of the output. You could have also mentioned equal variances. However, the Kruskal-Wallis test has equal variances as well. Part B was to circle and mark the response and explanatory variable within the ANOVA command. Part C was the sum of squares between treatment. Part D was the mean squares within treatment. You were then asked why the degrees of freedom for the residual was 24. Well, in the question you were told there are 27 subjects. You know that there are 3 different drugs being tested. So 27 minus 3 equals 24 degrees of freedom for the residuals. You were then asked to interpret the ANOVA result. So you could have done this by stating that the average level of pain experienced by volunteers when using at least one of the 3 drugs that was administered was significantly different. F value of 11.91, degrees of freedom of 2,24, and a p-value of 0.000256. The level of significance you used, and actually you use in all of our tests, is alpha equals 0.05. You are next asked for the 95% confidence interval for the non-significant pairwise result. So the difference between super and relax was the only comparison in which the p-value was greater than 0.05. The confidence interval is therefore here from negative 1.39 to 1.17. Finally, you are asked to put letters on the plot. From the post hoc test, we can see that relax is different than magic, so they must have different letters. Super is different than magic, so they must also have different letters. However, super is not different than relax. So if we do something like this, it should meet all of those criteria. Last question. To estimate this variation, we just divide habitat sum of squares by total sum of squares to get 33.9%. Young trees in each habitat, well, the total sample size is 20, as we can see that the degrees of freedom equals 20 minus 1 equals 19. Half of the trees are in each habitat, so 10 in each habitat. And then within each habitat, we've got 5 young and 5 old trees. An interpretation of the ANOVA table here requires that you provide a statement for each of the 3 F tests. There are 3 because this is a two-way ANOVA, so there are 3 null hypotheses. I've listed them all here for your reference. I hope that this video helps make some things that you are perhaps having trouble with a little bit clearer. As we move closer to the exam, please keep positive that anything you're struggling with, you will get your head around if you just keep working hard on it. The only chance you have to succeed and do better is right now. So take the chance and see how well you can do. You never know, you might just surprise yourself, in which case you'll have no problem coming up with a very exciting tweet or Facebook post about rising to the challenge of BI 206. Go team!